Hello everyone. So today let's discuss about the high-level design of distributed job scheduler. Uh, for for performing any system design, the basic flow that we usually follow is first we define what does that particular component or the question mean. Moving ahead with functional and non-functional requirement. After that, we describe what all entities we are gonna use for that. Following that, we'll talk about the API design. Then we'll draw a basic high-level design of the particular system, and finally we'll dive deeper into the components or certain aspect of the question. Okay, so let's start with the distributed job scheduler. So basically, what is a distributed job scheduler? When we talk about it, what does it mean? So a distributed job scheduler is nothing but a system which schedules or execute a task at any specific time or any interval of times, right? So let's say, for example, we have a use case of the email camping. The marketing team, they wants to send email to their target audience at certain period of time, right? Or we wanted to perform database cleanup in our system or our project. We want to generate reports, perform auto payment processing, etc. So all these tasks comes under job scheduler. Okay, so now as we know the functionality of job scheduler, it basically consists of two components. One is a task which defines what has to be done, the work that needs to be done. For example, in our email campaign, the task is nothing but the email that has to be sent. However, job is nothing but the requirement in order to execute the task. So for sending an email, when do you want to send the email? What are the parameters that has to be there while sending an email? For example, to, from, subject, body. These are the requirement called as job for the job scheduler. Okay, now talking about functional requirements. So as we talk about functional requirements, let's define a couple of them for designing distributed job scheduler. So first will be definitely user can schedule the task immediately or at any future date, right? So let's quickly write that: immediately or in some future date. And now as we are talking about future date can be specific or can be recurring. Okay, the second requirement would be the user can basically monitor the job which he has set up at any scheduled time. Okay, so these will be two main functional requirements. For now, let's keep cancel or reschedule job as out of scope. So we'll just write it down. Our out of scope functional requirement will be canceling or rescheduling jobs. Okay, now coming to the non-functional requirements. So the first non-functional requirement will definitely be the system should be highly available. So here, following the CAP theorem, we are prioritizing availability over consistency. So let's quickly write that. Available, and when we say highly available, we want to make the system around 99.99% available, right? The next NFR would be the job should be able to execute within 2 seconds of, let's say, schedule time. So 2 seconds of the schedule time. The third one will be, as we are talking about high availability, we have to make sure that the system should be scalable as well. So how are we going to define scalability? For now, let's say the system should be able to send 10K jobs per second. Okay, and finally we want to ensure that there should be at least one time execution of job should happen. So these are the four main non-functional requirements. System should be highly available. Jobs can execute within 2 seconds of schedule time. It should be highly scalable. That is for 1 second, 10K jobs can be sent. And finally, we have to ensure that at least one time execution of job should be there. Okay, so now we have defined our component, we have defined the functional and non-functional requirements. So moving forward, let's talk about entities. So, and when we are talking about entities for distributed job scheduler, four things come up with the mind. First is who wants to send the job or the task, right? Who wants to execute this? So first entity would definitely be user, the one who is submitting or mingling with the job. Then the next entity is definitely gonna be task. So you remember in the early stages we defined that a job scheduler consists of two parts. One is task, which specifies what has to be done, and second one is job, which tells when the task has to be executed and what are the requirements to execute the task. So we have user, we have for every user we'll be having task. Let's Yeah, and then we have jobs as well. So jobs are nothing but basically the requirements that we are going to define. And then finally we have to define schedule as well, that whether the job is going to be cron job for, or a specified daytime job, etc. So these four will be the main query, the main entities that should be there within our distributed job scheduler. If you have any other entity which is coming up in your mind, please type that down in the comment section, and we can discuss about the same as well. Okay. So taking one example, let's say of email generation. In that case, user, who's going to be the user? The marketing team is going to be the user. Jobs, since the email campaign has been set up, so the email campaign with multiple email tasks to send, let's say, 1 million emails to the user or their target audience is going to be their task. Then we have the job, which defines when the particular emails has to be sent. And then finally schedule, job is going to determine what are the requirements of the task that has to be sent. And then schedule will talk about the specified duration via when the job has to be executed, right? So this is basically about that. And after that, let's move, since we have already completed the entities, next we are gonna talk about the API design, right? So talking about the API design, what will be our first API as we talk about it? So our first API would should definitely be about post, right? Because we want to execute a job, right? So we'll say post jobs. And while defining post jobs, what should be our request body basically? So first is definitely it should be user ID, right? So we'll have certain user ID, let's say John for now. After that, we want to have task ID. Okay. After task ID, similarly, we'll be having job ID. Once we have the job ID, we'll need certain parameters, right? So now parameters, let's define parameters. What all parameters should we be having? So first one, for email we want to have two component to, let's say, ABC. Then we'll be having the subject of the email. Okay, so email sent, email subject for now. Then we'll be having body type, or let's say message, hello Sam. So this will be our parameter, right? And then after that, yeah. So this is the basic request format. Now, what is the problem do you see here in this particular request format? The first problem that we can see over here is basically we haven't defined when the task needs to be executed, right? So we need some schedule for the same. So let's define certain schedule. So for that, I'm defining a schedule parameter. Now, when we are talking about schedule, again, there can be two components. One is the job can be a cron job or the job can be sent to a specified time, right? So for that, we need to define one parameter which will tell what is the type of the job. And this will again be an enum which will tell whether the job is cron job or a specified job with certain date. Okay, and then after the type, the next will be our expression, which tells if it's a cron job, then give certain values, or if it's a date, specified date, then tell the expression about the same, right? So this will be our schedule. After that, also for our parameters, for now we have defined two, subject and message, but what if this particular job scheduler is not for email generation, and we have to make it extensible for maybe database cleanup or for auto payment processing? At that point of time, we need certain other values, right? So for that, we need to define first is what is the type of job that we are going to perform, and based on that, if it's an email, let's say, then we can give something about this. If it's not an email, then maybe we have to type certain other data. So for that, we can type certain data, and then in the data basically we'll be sending all these details. Okay, so yeah, I think this looks good. And then after that, at the end, we can always define the status of the job that we have executed. So is it in pending status, has it been completed, etc. We can talk about this, right? So this is basically the API design that we have come up with for posting a particular job. Now, let's come for the high level design. Okay, so for high level design, what do you think? What does the high level design of job scheduler looks like? So, for any system, first thing that we are gonna have is basically a client, right? So, we'll define a client. After client, we definitely need some basic uh, scheduler service. So maybe we can define, or even before that, let's define a gateway, because client will always send a request to via gateway, right? So we need this particular gateway for us, and the gateway will takes care of, when we're talking about gateway, it can act as load balancer as well to route the request, perform authorization, authentication, and other performance as well, right? So we can always customize that. Once the client request passes through the gateway, we'll be having certain scheduler service. So we can write schedule service, which will trigger the type of job that we want to execute. After this, we definitely need the data storage that we'll be having. So for that, we'll be having, let's say, our DS distributed job store that we have. For here, we'll be storing all the data, the entities that we have defined. Once the data flows through here, finally we'll be having certain workers who will be picking up the data at regular period of time via polling. So over here we'll be having certain workers, let's say, who will poll the data at regular interval of time and see what is the next job that has to be executed. So basically, this is the a high level design or the basic flow that we can talk about, wherein the client sends a request to API gateway. From there, we'll have a scheduling service which will execute the job, and after that, it will send it to data store. And then, based on the type of jobs that we have, be it cron or date specified date time, we have a worker defined which will basically do polling from the data store at regular interval of time to get the details and execute the job again and again. So this is the basic structure, right? And then for there, for even for monitoring purpose also, we can always have one other call uh, via worker itself, which will monitor the data and send the details back. So now basically this is the basic flow, right? Now what happens is, if we want to deep dive, let's say for our non-functional requirements, so we have covered all the functional requirements wherein user can schedule task immediately or in some future date, or user can monitor the job of the scheduled at a particular at any given time, right? Coming to the NFRs, so we have to make sure the first thing is the user can execute a job within 5 seconds of any schedule time, right? So for this, do you think that if we are making a call, the call has to be sent within 10 seconds? Because it's not just a flow. When we are adding networks, it will add latency to the system, and there are various other components. If we are performing horizontally scaling or we are creating replicas, it's not possible to manage everything, right? So at that point of time, with the current architecture, it's not possible to hit a 20K job or 10K jobs in 1 second. So we have to come up, or we have to modernize this architecture. For that, what we can do is basically we can add a message queue, right? And then for that message queue, what happens is whenever we are posting any records in our data store, at that point of time, we can have a message queue wherein at, let's say, for every 5 minutes that particular queue will run. We'll see which is the next upcoming records that we are having, or the jobs that has to be executed, and for all those jobs it will put that, order that, and maybe sorted order, and then put that into the message queue, so that from message queue it can get picked up by the worker and executed at the first come first serve order, basically, right? So for that, we don't have to worry about every second. We have to hit the database system, get the records for 10K, and execute all of them at any given point of time. We don't have to worry about that, right? So let's maybe redesign this. As we talk, we can't directly add now worker, because from our job storage, basically, we have to have a certain, or maybe what we can do is we can keep worker, and but from the worker, we have to send this data to a queue. Okay, so we'll have a queue. This queue can be Kafka or RabbitMQ, and from this queue basically will get the details. So worker will pull the record from the job storage, and from there it will send the data in sorted order to this message queue. And once it send the data to the message queue, we'll have another worker which will pull the data in first come first serve order, basically. Okay, so this will pull the data in first come first serve order, and this will send the data in sorted order. So now we are not hitting or querying the job store at 10K calls at 1 second. We are basically, for every 5 minutes we are hitting it, getting the latest records that has to be executed, sending it to the Kafka, and it will take care of the rest of the execution. Does that make sense? Okay. Now for this, we have multiple approaches. First is via Redis. We can use sorted set and use them as the priority queue to put the data. But what will be the issue for that? The issue will be then a lot of overhead we have to perform, because then we have to design the retry mechanism, the failure handling mechanism, the replication strategies. We have to take care of that. However, we can go ahead with the second approach, wherein we can directly make use of Amazon SQS system, which is fully managed queue service. It can have its own, it has its own retry mechanism. It also support exponential backoff, so that we don't have to worry about any of the designing mechanism. It's all built-in functionality, and we can just put the message in the Amazon SQS, and from there the worker can pull the records. Okay, so instead of using Kafka, RabbitMQ, or Redis sorted sets, we can directly make use of SQS. Now, if this does make sense, let's go with the second requirement, wherein the user should be able to support 10K jobs. Now, here again, when we are talking about a scheduler service, at that point of time, at one point of time, 10K clients, and clients, when we are saying clients, we mean API calls. So 10K API calls are hitting API gateway and then hitting scheduler service. So this is not again a feasible requirement, right? Although for a small scale system, it's always better to keep the design simple, but as our system scales, that point of time we have to take care and make our system more and more scalable. So for that we have to basically redesign this particular component as how can we handle 10K calls in 1 second without being a bottleneck. So here's scheduler service is a bottleneck, so we have to design something over here, right? So for here again we can add certain queue, and this message queue can be again a Kafka or RabbitMQ between this API gateway and the job creation, which will act as a buffer during the peak hours. So during peak hours, what we can do is we can, instead of directly posting it to scheduler service, we can put it into the message queue, and from message queue it will pick up the records one by one, send it to the job store, and get the rest of the task done. Okay, so here let's add a service. We'll move this. Message queue, let's say Kafka is over the first. The system will go to message queue in the peak time hours. For normal hours we can directly hit the system, right, the scheduler service, but for peak hours we can send it to message queue, and from message queue it can go to the scheduler service, and from here the rest of the task can get done. Okay, so this is about handling 10K calls in 1 second. For handling the peak hours, this should be our design, what I have come up with. If you have any other design, if you want to make use of any other tech stack, let me know. Thirdly is basically, so we have covered scalable 10K jobs, we have covered the execute within 2 seconds of schedule time. Now we have to ensure that at least one time execution should be there. So what if there's for any of the job there's certain bug because of which that particular job couldn't execute, or any particular, at any given point of time the worker gets down. For that point of time, if the job has to be executed, how to handle that? So again, if we are using SQS, since SQS has built-in feature wherein it can implement retry mechanism, it has the exponential backoff, we don't have to worry about anything. And also if after multiple retries the system is not executing any particular job, it can always put it into that later queue, and from there the developer can pick it up and see, monitor about it, right? So we don't have to worry about all these things. And there's one more component called as visibility timeout. So what happens in visibility timeout is, whenever let's say any worker has executed a message, at that point of time all the replicas of the worker, so let's say we have multiple workers over here who are executing jobs at any given point of time, right? So for a particular worker, if the job has been executed, then all the other workers will delete that particular job from their queue. And if by any chance during execution there is a bug because of which it couldn't able to execute the job, the other workers will get the job back, the task ID, and make sure the job will get executed next time. So this is called as visibility timeout, wherein we can set the timeout within the message queue, so that the worker will pull up the records, perform the execution, and if it's completed, delete that particular task ID or job ID from the other workers. Okay, got it? And finally, talking about idempotency. So here we have handled the failure jobs. Now, to make sure that job is getting executed only once, we can always make use of idempotency key in our API to make sure that okay, the job has been executed. We have also conditional operations wherein the downstream service should check if the operation has been executed or not. If not, then execute it again. Something like this we can always implement it. So I think this is about the job scheduler service, wherein we have defined the job scheduler, we have defined the functional, non-functional requirements, we have talked about entities. When we are talking about entities, since we have given availability, we have given priority to availability rather than consistency. I think the database should be DynamoDB over here. Again, there's nothing like we can't give availability in terms of the SQL database for, but however, since we don't have to do a lot of consistency or joins, we can always go with DynamoDB or Cassandra. Then we have done the API design. After API design, we have talked about basically the high level design that we had, and we potentially deep dive into various components like handling 10k jobs in 1 second, execute within 2 seconds of time, and finally execute at least one time execution of the job. So I think this is about it. If you have any other question, let me know. Else we'll see you in the next video. Bye bye.